I'm really excited to get into chapter 10 with you. Chapter 10 is all about geometric figures, and I find this a really interesting topic. Different people have really varying relationships with geometry. Some have great experiences, others not so much. There is a lot of terminology in this unit, so be prepared for that as we go through it. Some of it I'll go through fairly quickly because there is so much, but you do have access again to the online textbook, and then of course the slides that accompany this. And so I'd really recommend that you go through and review and study and prepare, maybe make flashcards for a lot of the terminology, especially if it's stuff that you are unfamiliar with. Some of these things you may have heard these words before, but maybe it's just been a while, or maybe you've just forgotten what they mean. Others, I'm sure, will come back to you. And so that's my one recommendation. Spend a lot of time with the terminology in this chapter because there is a lot. Let's give it a shot. 10.1 is titled Plane Figures. So this section is all about plane figures. There will be 3 sections in this chapter. And as you can see, as I mentioned, there is a lot of terminology here. We'll start with a spotlight on teaching and learning. We'll talk about just what is geometry, a brief introduction to mathematical systems, terms that go along with that. Then points, lines, and planes, terms that go along with those. Angles and their terms, types of angles, perpendicular lines, curves and convex sets, circles, polygons. You can see how many terms there are just in this one section. I didn't even bother to name them all. You can certainly pause and look through that. Also, for your own note, at the end of each unit or end of each chapter in the textbook, if you haven't seen this already, if you go to the e-textbook, you go to the very last page, and it has a summary of all the terms from the chapter. And we're not going to be covering everything in this chapter. There are going to be things that we do skip. And so just do note the things that I have referenced on this introductory screen. A quick spotlight on teaching and learning. We often think of geometry as a class you take in high school, often in 9th or 10th grade, maybe. But really, the ideas of geometry are starting really early. Kindergarten, 1st grade, you're starting to build the idea of those 2 and 3-dimensional figures. Grades 2 and 3, you start to identify, describe them, categorize them, note their features, and putting them into groups, right? And then grade 4, you start to build that terminology, points, lines, rays, angles, etc. Again, there's a classification that goes along with these things, right? So much of learning math is about learning how to think critically, think analytically, put things in categories, make observations. That's what mathematical thinking is all about. So I've got a little starting activity that I'm not going to spend much time with in this video, but I think it's good for you to try. And so what you'll see here is a picture of a triangle that's made up of other figures. And again, decomposing and recomposing geometric figures is something that the Common Core state standards do ask students to do. And so this is just a chance for you to play around with it. I'm not giving you any right or wrong answers on this, but if you can sketch something like that out, cut it out, and then try to accomplish these goals with those figures. Again, I think that's a really good just starting point for your thinking about what do my students really need to know. So geometry, let's get into some terminology, lots of it. Like, what is geometry? Well, it's comes from the Latin word, and it means earth measure, right? Geo, you think about the prefix geo, geology, right? Geography, all those have to do with the earth, with the world. And geometry is literally about measuring the earth. So many things in mathematics stem from real life needs. And how do we measure our plots of land and how much space we own and how to segment property, right? Thousands of years ago, Egyptians, Babylonians were using geometry. They would survey, building their architecture. They made all these observations and they used that in their buildings. They started to discover geometric facts and relationships between certain things. They experimented. They used inductive reasoning. Remember the idea of inductive reasoning, but because it was inductive reasoning and not deductive reasoning, they could never be totally sure of their conclusions. And sometimes they did make some mistakes in their formulas that they built. Ancient Greeks took a different approach. They viewed points, lines, figures more as abstract concepts that they could reason deductively about. So they did experiments, but they led to this idea of proofs. Can I prove something to be true? And if you ever took a geometry class, you have to learn about how to prove things. That's sort of a basis of geometry. And that's the beginning of this idea of building a mathematical system. Unfortunately, when you're going to prove something, you have to start out with some assumptions. And again, this is giving you just a foundational idea about what geometry is. You won't necessarily be tested on this, but it's good to know where this background comes from. And so again, mathematical systems consist of undefined terms, definitions, axioms, and theorems. We can't define everything. For example, a line is actually an example of an undefined term in geometry. It's one of these things that we kind of know what it is, but we can't really define it in a way that helps us build upon it. Axioms are things that we do assume to be true, but we don't always try to prove, right? So all of geometry is based on these axioms, things that we assume to be true, but it's sort of really challenging to prove. And then finally, axioms, definitions, undefined terms are all used together with the process of deductive reasoning to prove statements, and then these statements become theorems. We've heard of theorems. The Pythagorean theorem was in your last chapter in this course, actually. So let's talk about some of these parts of geometry. We talked about points, right? Points are really an abstract idea. We tend to say, okay, put this point, and it's a dot, right? It's something we draw, but it doesn't have any dimensions to it. It doesn't have width, it doesn't have length or thickness. So it doesn't have any dimension to it, but we just understand that it sort of exists, okay? Similarly, a line is a set of points, and we describe it as being straight. We say it extends both ways, in both directions forever. But again, it's hard to really define it. What you're going to see here is a line. And on that line, there are 2 points. Now, when we are describing a line and we can name it. And so because this line here, again, it extends in both directions, has points A and B on it, we write it like this, AB with a line, and we extend those arrows in both directions. This is the notation for line AB. We always, when we're asking questions or referring to a specific part of a drawing, we want to make sure we're referring to the right part. And we often do that with notational devices like that. Now, in this example, we also see that we have points A and B lying together on the same line. And so we say that points A and B are called collinear, okay? So those points are collinear. 2 or more points that are on the same line are called collinear. So another important concept in geometry is called a plane. And in fact, that was in the title of this particular section. And so what is a plane? A plane is actually another set of points, but instead of being just in a straight line, it's flat like in a table. And so if you're trying to explain this to young students, you might even have them use their finger to represent a line and their flat palm to represent the plane, right? So a line is just, right, with your finger, it goes in a straight line, but then the plane is a flat space. Again, like the table, right, that they might even be writing on. But it does also, like a line, extends sort of indefinitely in all directions. So it's flat and it goes in all directions. And so a couple of questions for you to think about regarding these ideas. If you had a piece of paper in front of you, what part of a sheet of paper might be used as a model for a line? What part might be used as a model for a point? And what part, or how can these models be obtained by folding a sheet of paper? We're going to do a lot of this later. And so if you think about a piece of paper, if you have a piece of paper in front of you, you might think of the edge of the paper as representing a line. So the edge of your paper represents a line. The corner of your paper, the corner might represent a singular point, right? And so two edges of your paper represent lines, and they come together at a single point. And you can also represent these by folding. If you fold your paper, then you have a new line right across the middle of your paper. If you fold that paper again, in fact, let me stop sharing, go back to just me, right? I've got a whole lot of papers here in front of me, right? If you fold your paper again, what you have is, now you've got a line going this way, a line going this way, and they intersect at a point right in the middle. We're going to be doing some of that later. So maybe have some extra paper out to play with these things a little bit. So again, these are questions that students can easily answer because they'll just have paper to play with. So what's next? Line segments. Sometimes we deal with lines that don't extend forever in both directions. And so a line segment consists of 2 points on the line and all the points between them. So that's what a line segment is. That's what you're going to see again right here. So this is line segment AB. Notice how this is written different from before. AB, it just has a line. It doesn't have the arrows on either end. And that's because it ends at A and it ends at B. And it has a bunch of points between it. Okay? So again, it's customary also when we are referring to the length of a line segment, we remove the line above it. So if we are talking about the length of line AB, we would write it like that, okay? And so that's, again, how we would note that. Another term we use in geometry is bisect. And so what does that mean? To bisect a line segment means to divide it into two parts of equal length. In this drawing up above, line C is right in the, or point C is right in the middle. And so we would say C bisects line AB, meaning this and this are now equal line segments. And C is the midpoint. It's what's right in the middle of it. Sometimes we look at a line that is only going in one direction, and we call that a ray. So it extends in one direction. The ray consists of a point on a line and all the points in one of the half lines determined by that point, right? So what you're going to see here is D as an endpoint, right? So D is the endpoint, and it extends to the right, going on forever. Because we also have point E on the line, we can then name it point or line DE. Let me get it right. DE. And because it's a ray, it's starting at D and going in the direction of E forever. And so that's how we would note that with that notation. Okay, so D is an endpoint and it contains point E in it. Next, we have angles. So what is an angle? So the angle is the union. Remember what a union is? Right? When you bring two things together and join them, a union of two rays, and they have a common endpoint. And so here's what an angle would look like. And we'll talk for a moment about how we note that, how we define them, how we describe them. And so what you'll have here is GF. GF is a ray, right? This is a line that goes in that direction forever. GH is another ray, but they share point G, right? That is their common endpoint. That's what we see right here. And the way that we name it is we write angle FGH, often with an angle sign there. Sometimes we put our little arc right there. And note the order that we put these letters in. The point that they share goes in the middle. So it's FGH. So whenever you're naming an angle, it's FGH with that point in the middle. And the endpoint that they share also has a name. It is called the vertex. The vertex is the endpoint that the angle shares. Now, sometimes, depending on the situation, we may just refer to our angle as, or the angle as the singular letter at the vertex. So sometimes we will just call this angle G, because it's the only angle that exists at G. Sometimes we need to write all three letters. We'll see that later. And other times we can just state the single letter. Sometimes we might number. If we have a bunch of different angles in a figure that we're looking at, we might number them. And so that's what we would see right here. This is angle 1, so we can call it angle 1 with that notation. We also sometimes want to indicate the measurement of the angle. We're going to learn about that later, like how big is this angle? And so maybe we have two figures. Here's another one, and this has that angle, angle 2, and we want to indicate that those two angles are equal. So we can write M, the measure of angle 1, is equal to the measure of angle 2. And so that's again just another piece of notation that we use. So that was a lot, right? I threw a lot of different terminology at you there, but that's going to lay the foundation for all the rest of our videos in this chapter.